The next speaker will be Phil Best. I'll follow that, and then we're back in sequence with Bruce McNaughton. We will take a 5-minute break somewhere in the middle of this sequence because it gets a little long, but a 5-minute in-place break. Phil is a convert, and he's going to tell you about his conversion a little bit and tell you some of the early stage work.
Thanks, John. This is an official picture of this guy who I met.
There.
Who I met in.
Oh, it's only real if it has white hair.
I met Jim in 1965, so that might make me the oldest person to know Jim Ranck in this room. I had just arrived in Michigan to do a postdoctoral fellowship with James Olds. And we had a very simple proposal. And my postdoctoral proposal reads something like this. We're going to record from cells in various parts of the brain while the animal undergoes various behaviors. And thus, we're going to figure out how the brain works. That was for a 2-year postdoctoral proposal. We didn't quite make it, but one of the things I learned, one of the things Olds gave me to do my first week as a postdoc, he said, you know, even though this is a research postdoc, you're mathematical, aren't you? I said, well, yes. My bachelor's degree was in math. My PhD was actually in mathematical psychology. He said, good. I want you to tell the students about neurophysiology. Just start with Hodgkin and Huxley and read the Hodgkin-Huxley papers. So I read the Hodgkin-Huxley papers, and boy, I tell you, it wasn't terribly easy at that time for considering my background. And so he said, you know, if you want some help, go over and see Jim Ranck. He knows a lot about it. And that was my first encounter with Jim Ranck. Jim, what do I do? And Jim was not at all cynical or snide. He was very helpful. And I got to know that this was a really special person. Now, to give you some idea of the time, in 1966, which is the era that was the year that Star Trek started on TV, I took a course with Jim. And Jim knows about this ball of thread more than anybody else because this is a graduate course taught to biophysicists, neurophysiologists, and a whole bunch of behavioral psychologists, some who didn't know anything about the nervous system. And Jim was trying to illustrate to them how long some neurons could be, how long could an axon be. So he held a ball of thread and he said, okay, he went to one of his postdocs. He said, now, why don't you grab the other end and go over to that door and we'll see how far you have to go. Well, if it's an 1/8 of an inch piece of thread, and some of these cells could be almost 1,000,000 times their diameter and length, the guy would have to go out the door, down the stairs, and go on the way to Ypsilanti before he stopped moving. Now, a lot of those people in that course didn't learn anything in that course except they knew how long a neuron was. So it was a very, very positive experience. I then left, as I was leaving Olds' lab in '68, I had a conversation with Jim, and he told me that he was thinking of recording single-cell activity in freely behaving animals, and I thought that was a pretty cool idea, except he told me he was going to use a neuroethological approach, and I thought, I don't know, Jim, you know, I was a Hullian. I was an American. I'm from Brooklyn, actually. I'm a Brooklyn American Hullian. That meant that I thought if you use any cognitive term to describe what an animal is doing, you're not being scientific. Pavlov would fine his students a ruble if they ever used a cognitive term to describe his dogs. So I was one of those people who didn't believe that rats thought or had any ideas. But I thought, well, we're still going to figure out how the brain works. The problem is we were using primitive techniques. And so over the first 6 years I was at the University of Virginia, I used these very primitive techniques. Large electrodes, 62 micron in diameter. Now, if there's a neurophysiologist on your study section, they're not going to find this very compelling. We also implanted the electrodes in anesthetized rats, and then we would cement them in place. We'd put about 8 in, and then when the animal woke up, we would actually see cells on 2 or 3 of these electrodes. Turned out eventually we learned that one of the reasons for that is if you want to see a complex spike cell fire really quickly, anesthetize the animal. Because cells that are silent for hours will fire as soon as you anesthetize the animal. And we actually found out, we actually were able to eventually report on the percentage of cells that were silent in the awake animal where the cells hadn't been lost. But the other thing was we had the wire come out of the animal's head, and way on top of the animal, about a foot away, we had our preamplifier. Well, that meant that the signal had to get from the head to the preamplifier, and if you use a normal shielded wire, if the wire bent, the capacitance changed, and the signal went away. So we used these microdot wires, which were very harsh on the animal. And we were worried about movement artifact. So we studied sleep because then we wouldn't get much movement artifact. And most of my studies in those days were sleep and arousal. And the other thing was we found some changes in the awake animal, but they were not impressive. I was not blown away by them. And I was worried because I thought, if I'm not blown away, something must be wrong. And I had interacted with Jim at a number of neuroscience meetings and noticed how well he was doing. And I was totally impressed by his array of descriptions of different complex spike cells. And also at that time, we weren't getting many theta cells because if you implant the electrode in an anesthetized animal, the theta cells are very quiet. So we only got 2% theta cells, and we just threw them into the batch, said, we're not going to hide our data, so we'll just throw them in. They didn't have much effect on the complex spike cells. But, so I'm looking at Jim's fantastic research and how cautious he was, and that he actually was avoiding using cognitive terminology to discuss his cells. He was purely behavioral. And I kind of like that because these other guys from England had recorded from a zillion cells, and 7 of them showed some sort of place field. And therefore, the hippocampus is a cognitive map. So I thought, these guys don't know what the hell they're talking about, so forget them, forget it. So Jim taught me how to do this thing. I was putting the etched tungsten electrodes in, moving about, and I was kind of frustrated because I wasn't getting great isolation, but finally one day I got isolation, and I'm studying the cell, and I run into Jim's office. Hey, Jim, you got to see this. Now, I have to tell you, at the time, I was a little cynical about O'Keefe and Ostrowski. Jim wasn't. In fact, at the closing of his 1973 paper, I guess John gave you some of the comments, it was basically, he concluded, they all might be place cells, for all I know. They all might have a spatial correlate. So let me see if I can get, where? Okay, I want to see if you can, I'm hoping you can pick this up to get the noise of this thing. First cell on this side of the Atlantic. So these crowds. What crowds? I put the animal through all the paces. Put food over here, draw it over here, the animal would come after the food. It's an approach cell. Take the food away, the cell would still fire. It was an approach mismatch cell. Oh, sorry. It was an approach mismatch cell. Anyway, so I called Jim in, and Jim looked at the cell, and I wasn't going to tell him what I had found. And I said, why don't you take a look at the cell? So I moved the animal around, and Jim kept thinking, oh, is it an appetitive cell? Is it an approach mismatch cell? Is it this, that? And all of a sudden you hear Jim say, oh my God, this is going to make John O'Keefe so happy. We actually have it on our tape. Sorry I didn't bring it with us. But so the fact is, my God, how do we do it? Well, Jim was very aware of the fact that this could be considered very subjective unless we took tapes of the animal. Now, we're taking tapes in 1974. There were no VHS recorders in those days. It was all reel-to-reel. And the reason this has not got such great acuity is it was reel-to-reel 1974. moved it to VHS and then finally digitized it, and it lost a little bit in each of those situations. So the idea was, we're going to make these tapes, and then we're going to show them to naive observers. Now, how are we going to find naive observers? Easy. I took them back to University of Virginia to a class of students that I had just taught a course in physiological psychology to. I knew how naive they were. I had made them that naive. I never referred to hippocampal place cells at the time. Well, we made 23 tapes, but we made 14 tapes of complex spike cells. 9 of them, the students were supposed to describe what was going on and then tell me what they saw. 9 of those cells were judged almost unanimously as something with respect to the position in space. 2 were related to a turning motion, 1 to drinking, and 2 had no sensory correlates. We also made 3 fake tapes. That is, we played yesterday's cell on today's animal. Luckily, none of those had behavioral correlates. Okay. And then we had 5 theta cells, all related to general motion, general movement. So all of a sudden, I became a believer. Now, in order to present this data at the neuroscience meeting, it was the 5th neuroscience meeting in 1975 that was held at New York City. I was so happy that Jim moved to Brooklyn, my hometown, because I had no reason to go to Ann Arbor anymore, but I had plenty of reason to go to Brooklyn. I had so many friends and family. And since then, I probably have been to his lab 30 or 40 times since he's moved to Brooklyn. In the meantime, I ran into David Olton. And David and I ran into each other, and he said, "Phil, I got to tell you about what I'm just doing." I said, no, I got to tell you about what Jim and I found. We finally got to talking, and I said, "Hey, Dave, why don't you come to my lab?" His father happened to live in Charlottesville. "Why don't you come to my lab, and let's do place cells on your apparatus." Now, again, this is way back before there were any way electronically of tracking the animal. So one way of tracking the animal is put the animal on an 8-arm maze, and you just press a button when the animal's on arm 1 or 2 or 3, but you don't see or hear the cell. So it can be much more objective. And I should be able to get this one. Oh, here it is. So this is not a Dave Olton cell. This is a cell by one of my graduate students, postdocs, Virginia Miller. This should only take a minute. Okay. Is it an arm 3 cell? No. Well, maybe. A few blips there. Not really. I think it might be an arm 1 cell. Well, it looks that way. What we decided to do was rotate the maze to make sure that the animal couldn't read. So remember, it fired on arm 1. Uh-oh, he can't read. Now remember, it didn't fire on arm 3, but it is now in arm 1's position, so now it fires there. So we decided this was a much better apparatus to use. If you're looking for place cells, you want an apparatus that reveals it to you. And John had already done that in his studies, but the box we were using at Jim's lab wasn't really the best thing to do. And here's the data revealed just graphically, and you can see the cell fires on arm 1, doesn't fire on arm 3, but fires on arm 1. Then we rotate the maze so that arm 3 is in arm 1's position. You can see it fires on arm 3 and not on arm 1. The other thing I learned about in the Ranck lab was the QB microdrive, and John might say more about it, but again, it was simple, elegant, and it worked. I had tried to make stable, movable bundles, but couldn't do that, or even a movable electrode outside of the one that Jim had developed. And so I stole the QB microdrive. Oh, by the way, we had 2 meetings, one in Anaheim about 1975 or 6, and it was John, Lynn, Dave Olton, Jim Ranck, and myself, and then another one in Toronto in 1988. So by then you'd think everybody believes in place cells. You might not like the theory, okay, we'll let you think about that, but do you believe in place cells? So this is a grant review I received in 2004. I still laugh. I know who wrote this. I'm not going to tell you. But I still laugh in his face. Thank you very much. Okay, thank you.